Good morning, students. Myself is K. Pradeep Kumar, working as Assistant Professor in Mechanical Engineering Department in MVR Engineering College of Technology. See, in this lecture, we are going to learn about boiler mountings. In the previous classes, we have studied about the boiler mountings of water level indicator, steam stop valve, and in this video, we are going to know the remaining boiler mountings. See, coming to the first boiler mounting in this lecture is about the steam stop valve. See here, we can observe the diagram of steam stop valve. Here we are having the components, how it is going to work here. This is the hand wheel, which is used for rotating in clockwise as well as in anti-clockwise direction. And these are the nuts. And this is the gland. And this is the stud. This is the body. And this is the spindle. And this is the way how the steam enters outside. And this is the valve seat. And this is the valve here. And this is the steam in. Hence where the steam is going to be entered into the boiler. These are the some of the components of the steam stop valve. See, coming to the functioning of this steam valve, to regulate the flow of steam from boiler to the steam pipe or from one steam pipe to other. See, this is the function of the steam stop valve. See, to regulate the flow of steam from boiler. See, we are going to regulate the steam from boiler to the steam pipe or from one steam pipe to the other is nothing but the function of the steam stop valve here. See, coming to here, we are going to know the construction of the steam stop valve. See here, we can understand the flange of valve body bolted to the boiler at the highest part of steam space. Here, this is the flange which we can observe here. See, this valve, this flange of valve body bolted to the boiler means bottom of this flange we are having the boiler top position at the highest part of the steam space, means at the top part of the boiler we are connecting this flange here. This is what about the flange which we are connecting to the boiler top position. See, it consists of valve seat and nut. Here we can observe the valve and the valve seat. Upon the valve seat, the valve is going to be seat. The main body of the valve is made of cast iron and valve seat made from gunmetal. See, the valve is made up of cast iron and the valve seat is made up of gunmetal. See, the lower end of spindle connected to valve and upper end pass through gland. See here, the lower end of spindle. Here we are having the spindle from top to bottom in vertical direction. We can observe here the spindle. The spindle, it can see here the lower end of spindle. Here the lower end of spindle connected to the valve. It is connected to the valve which we are having here, the valve. And upper end. See here, we can show in the diagram. You can observe the diagram here. That upper end pass through the gland by it is going to pass through this gland which we are using here and yoke and connected with the hand wheel. This is the upper part is the upper end is connected to the hand wheel. See here, and the gland is used to prevent leakage of steam. The gland which we are using here is used to prevent leakage of steam. And when steam stop valve is placed directly over the boiler, and connected to the steam pipeline is called the junction valve. When the steam valve is placed directly over the boiler, see here the valve which is placed over the boiler and connected to the steam pipeline is called the junction valve, which we are naming here this valve as junction valve. And if it is placed near to prime mover, then normally called as steam stop valve. This is about the construction of the steam stop valve. See here, you can observe the different components, how we are going to construct this steam stop valve. Coming here, when we are going to rotate these hand wheel in clockwise or anti-clockwise direction, the valve disc which we are having is going to move in the upward direction, and hence from this is the way how the air enters or the steam which is going to be enters here into this valve body. And when the steam is going to be entered, the hand wheel, when it is going to rotate in clockwise direction or when it is going to move in the anti-clockwise direction, the valve disc opens and the steam is going to escape into this valve body. See here, we are having the glands which I have shown you in the diagram, crosshead, the spindle and the valve disc, and we are having the valve seat here. See here the working of this steam stop valve we can understand here. When it is going to rotate and the hand wheel is going to rotate in the clockwise direction, and when it is going to rotate in the anti-clockwise direction, then when it is going to rotate in the anti-clockwise direction, the valve moves upward direction, and hence the steam which is going to be entered here moves into in this direction. See here, when the handle moves in the clockwise direction, the spindle moves in the downward direction, and when the handle wheel moves in anti-clockwise direction, the valve which we are having here moves in the upward direction. When the spindle moves upwards, the steam is going to be entered in and the steam is going to be out. See, this is what we have observed in the first diagram, that we are having the stud here, and here we are having the gland which is used for not escaping the steam outside, and this is the spindle which we are having. When the wheel rotates, here the spindle moves up and down, and when the valve opens, the steam is going to be entered inside, and this is the valve seat. Upon the valve seat, we are having the valve and the spindle, and we are having the flange which is connected to the boiler topmost position. See, when coming to the working of this steam stop valve, the spindle is rotated by help of a hand wheel. See, we are having here hand wheel. The spindle which we are observing here in the diagram is going to be rotated by using of this hand wheel. Due to rotation of spindle, the valve moves up and down. See here, by rotation of this hand wheel, the spindle is going to move in the upward and downward direction. When the valve sits over the valve seat, here we are having the valve. When the valve sits on the valve seat, the passage of steam is completely closed. It means no steam is going to be entered inside, and the steam passage may be partially or fully opened by moving the valve up. When the handle rotates in anti-clockwise direction, the spindle moves upward and the steam is going to be entered inside this. The steam passage may be partially or fully opened by moving the valve up. When we are going to move the valve up, the steam is going to be entered inside. See here, the clearance between valve and valve sheet regulates the flow of steam out of boiler. See the valve sheet and valve. Here we can observe that this is the valve is the control of steam in and outside of the boiler. See here, in locomotive boilers, the supply of steam is regulated by means of a regulator which is placed inside boiler shell and operated by a handle from driver's cabin. In locomotive boilers, we are going to use such type of steam stop valves. This is what the working principle of steam stop valve. And coming to the next mounting, we are going to learn about feed check valve. Here you can observe here in the same way as that of steam stop valve. Here the feed check valve also works. See here, this is the hand wheel. The hand wheel is going to rotate in clockwise as well as in anti-clockwise directions. Here we are having the water to boiler, water in the boiler, and the spindle which moves upward in direction when the handle rotates. And this is the non-return valve. See, this is the non-return valve, and from here the water is going to be entered. See here the function. The function of this feed check valve is it is used to control the supply of water to the boiler to prevent the escaping of water from the boiler when the pump pressure is less or pump is stopped. See here the function of these feed check valve is that it is used to control the supply of water to the boiler. Means we are going to control the water inside the supply of water to the boiler, and to prevent the escaping of water from the boiler we are going to prevent the escaping of water from the boiler when the pump pressure is less or pump is stopped. See here we can observe the construction of these feed check valve. Here the feed check valve is fitted in the water space of the boiler just below the normal level of water. It consists of, here we are having non-return valve, water inlet pipe, water inlet pipe means this is the inlet, and we are having the outlet means nothing but of a delivery pipe, and this is we are having the spindle and gland end. We are having the gland, and we are having the hand wheel. Here the outlet pipe of valve connected with the boiler, outlet pipe which is connected with the boiler, this is the boiler, and inlet pipe connected with the end of the delivery pipe of feed pump. See here we can observe here how the delivery pipe is connected here to the feed pump. This is the construction of the feed check valve. What are the components which we are using in this feed check valve? And coming to the working of this feed check valve, inlet and outlet pipe of valve is exposes different pressures. See here the inlet, in the inlet and outlet of valves is exposed to different pressures. Means inside we are having one pressure and outside we are having the other pressure. At inlet of valve the feed pump pressure acts, and outlet pipe of valve the boiler pressure act. See here at inlet of pipe we are having, see here at inlet of pipe we are having feed pump pressure, and outlet pipe we are having boiler pressure. This is the outlet, this is the inlet, and this is the outlet delivery pipe. Here this is the outlet. At outlet we are having the boiler pressure, and at inlet we are having the feed pump pressure. When feed pump is in operation, the pressure on the feed pump side inlet is more than the pressure on the boiler side. See here when comparing with the boiler pressure, the feed pump pressure is more than that of the boiler pressure. Here the pressure difference lifts the non-return valve and allows water flow into the boiler. See here as we are having pressure at the inlet, what is the, when the water is going to be entered into the boiler, here at the inlet we are having feed pump pressure. We are having, due to the pressure which is having here, the non-return valve moves upward, means lifts us upwards. When the non-return valve moves, upwards, then the water or the steam is going water in, means the water is going to be entered inside. See here the pressure difference lifts. We are having the pressure difference. At outlet we are having boiler pressure, and at the inlet we are having the feed pump pressure. Due to the pressure difference here, means boiler pressure is low here, and when comparing with the feed pump pressure, at the inlet we are having feed pump pressure. The feed pump pressure is high when compared with the boiler pressure. See, the boiler pressure is low and the feed pump pressure is high. Due to the high pressure, due to high feed pump pressure, the non-return valve moves somewhat upward, in the upward direction. When the non-return valve moves in the upward direction, the water is going to be entered into this delivery pipe. See here, the pressure difference lifts the non-return valve and allows water flow into the boiler. Means the water is going to, when the non-return valve moves somewhat upward, the water is going to be entered into the boiler. The lift of the valve is controlled by moving the spindle up and down with the help of the hand wheel. Just due to this feed pump pressure, this non-return valve moves upwards, and it is and the water is going to allow into the boiler. See, for controlling such type of pressures or for entering the water into the boiler, we are going to control by using of this spindle. The spindle is used to control by using of this handle. See, when we are going to rotate the handle wheel in clockwise direction, the spindle moves downwards, and it is used to press the non-return valve from upward to downward. Hence, this non-return valve is going to sit on the valve. Non-return valve is again placed in the same position, and hence the water will not enters into the boiler. The lift of valve is controlled by moving the spindle up and down with the help of hand wheel, so flow water is controlled. See, if pump is fail or stop due to any circumstances, the pressure on pump side is lower than the boiler pressure. See, when the pump is going to failure here, then it is going to reverse here, that the feed pump pressure is low and the boiler pressure is going to be increased, and resulting the downward force on non-return valve is higher. Resulting the downward force on non-return valve is higher, and therefore valve sits on its seat and closes the passage. Hence, when we are going to rotate, the spindle moves downwards and sits on the non-return valve. These will prevent the backflow of water from boiler to the water pump. Hence, we are going to control the flow of water into the boiler shell. This is what about the working principle of feed check valve. Means the feed check valve is used to control the water which should not enters into the boiler shell. This is what about the feed check valve. And next mounting is about the blow off cock. Blow off cock means nothing but of removing the sedimentations or mud what it is there in the boiler bottom. At the bottom of the boiler, what are the sedimentations formed, we are going to clear by using of this blow off cock. See here, we can observe the diagram here. Here this is the guard, and this is the spindle, and this is the glands, and this is the casing, and here we are having a conical plug. See here, the blow off cock or valve performs two functions. Here, the blow off cock is used to function in two ways. That to discharge periodically a portion of water which contains mud, scale or sedimentations at bottom of boiler vessel while boiler is in operation. That when the boiler is said to be in operation, it is going to discharge a portion of water downward. See, which contains means mud, scale or sedimentations at the bottom of the boiler shell. We know that the water fed to the boiler which contains some sedimentations and dissolved salt, it is not converted to steam, but deposited on the bottom of boiler shell. So blow of cork useful to discharge the water which contains mud, sedimentations, etc. Means at the bottom of the boiler is used to convert the feed water into steam. Means the feed water which we are feeding into the boiler is not accurately pure. That the water which we are feeding is having some sedimentations, mud or scale, which the water which it contains mud, scale or sedimentations. The sedimentation water, feed water, cannot be converted into steam. So the water is used to discharge into the downward position of the boiler. Means at the bottom of the boiler, the mud, scale and sedimentations are going to be collected at the bottom of the boiler. See here, the blow of cork is used to remove such type of mud, sedimentations and scale forming below or at the bottom of the boiler. This is the function of the blow of cork to remove the sedimentations, the scale or mud which has been formed at the bottom of the boiler shell. This is the first function. And second one is that to empty the boiler when necessary for cleaning, inspection and repair. Whenever the blow of cork is having any problem inside, when for cleaning at that time or for inspection purpose and for repair purpose, we are going to open this blow of cork. This is what about the blow of cork functioning. And coming to here, the construction, we can observe here, this is the boiler shell, this is the Cohran boiler shell. The blow of cork where it has been located means at the bottom. See here, a common type of blow of cork is shown in figure. See here, it is fitted on the boiler shell directly or through the short branch of pipe at the lowest part of the water space. See here, at the lowest part, at the downward part of the boiler, the blow of cork has been fitted here. It consists of gunmetal conical plug having a rectangular hole. It is having a rectangular hole with yoke as shown in figure, and here the mud and water of during blow of is collected here. See here, the mud is going to be collected here. This is what the example which I am showing here. See, by using of this blow of cork, I am showing where the blow of cork is located in the boiler shell. See, coming to the construction, see, it consists of gunmetal conical plug having a rectangular hole spindle with yoke as shown in figure. See, coming to here about the blow of cork. See here, a common type of blow of cork is shown in figure here. It is fitted on the boiler shell directly or through the short branch of pipe at lowest part of the water space, which I have shown you here in the diagram. How it has been fitted, the blow of cork at the bottom of the boiler shell, and it consists of gunmetal conical plug. See here, you can observe here the conical plug having a rectangular hole. Here for this conical plug, we are having a rectangular hole here. A rectangular hole is there, and spindle with yoke. Here, this is the spindle which is used to rotate as shown in figure. And the plug measures accurately into the smaller casing. The plug is going to be accurate in smaller casing. This is the casing which we can observe here. This is the casing. Here, this is the part. We are naming this as a casing. And the plug spindle is generally rotated by means of a spanner on the top of the yoke. See here. The spindle is going to rotate by using of the top of this yoke. Means this is the wheel which we are going to rotate. The plug spindle is generally rotated by means of spanner. By using of spanner, we are going to rotate at the top of this yoke. and two vertical slots are provided for fixing spanner. See, this is the wheel which is used to rotate, and this is the yoke, and this is the shank, this is the studs, and this is the body stuffing box, and this is the plug and flange. When the wheel is going to this is what about the construction of the blow off cock. And coming to the working, see here, in order to operate the valve, the rectangular slot is brought in line with the passage of the body. Here the plug is brought in line with the passage of the body. This is possible by rotating the plug with the help of wheel. See, when we are going to rotate the wheel, the rectangular slot which we are having here, the conical shape, and the rectangular slot which we are having here is brought in line with the passage of the body. See, when we are going to rotate the wheel, that when the slot is placed in the position, the cock is opened and all impurities, mud, sedimentations, etc. start flowing out of the boiler and they are removed. Means, as here we are having the hole, the water is going to be flow here, and we are going to remove the mud and sedimentations here in the boiler at the bottom of the boiler shell. When the slot is brought at right angles to the passage of the body, the cock is closed. Here the cock is going to be closed. This is what about the blow of cock which we can study for removing the mud particles, sedimentations, and a scale which has been formed at the bottom of the boiler shell. This is about the boiler mountings, which I have studied about the steam stop valve and feed check valve and blow off cock. With this we have completed the boiler mountings, and in the next class we are going to start the boiler accessories. Thank you. If you are having any doubts, please contact me or mail to this mail ID.